Welcome to Ask and Learn.
In this problem, we have paddle wheel work, which is applied to nitrogen in a rigid container, and we want to calculate the final temperature. We assume that nitrogen is an ideal gas, since it is at a high temperature and low pressure relative to its critical point values. The kinetic and potential energy changes are negligible, and we can use the constant specific heats at room temperature for the nitrogen. Now, the specific heat for nitrogen at room temperature is 0.177 BTU per pound mass R. The gas constant R for nitrogen is 0.3830 psi foot cube per pound mass R. So the first thing we will do in this problem for our gas is look at the energy balance equation, which says that the energy in minus the energy out is equal to the change in energy of the system, delta E. Now, the only energy in is the work done by the paddle wheel, WPW in. And this is responsible for a change in internal energy of the system, delta U. Delta U can be written as M times CV, the specific heat capacity for nitrogen, into the change in temperature, T2 minus T1. Remember, kinetic and potential energy contributions are zero. So in order to use this equation, we'll first need to find the mass of nitrogen. The mass of nitrogen, since we assumed it's an ideal gas, we'll use the ideal gas relation. M is equal to P1V over R T1. And these values are all known. So the pressure is 20 psi absolute. The volume is 1 cubic foot divided by the gas constant R, which is 0.3830, and again that's psi foot cubed per pound mass R, multiplied by the temperature T1, which is 560 R. So now if we do this calculation, we get the mass of nitrogen to be 0.09325 pound mass. So we can use this mass in the energy balance equation and find the work done by the paddle wheel. The work done by the paddle wheel into the system is equal to mCV into T2 minus T1. So actually we are given the work done by the paddle wheel. We wish to calculate T2 in this case. So this is 5,000 pound force feet, and we'll convert this to BTU, since we know that 1 BTU consists of 778.17 pound feet of force, and this is equal to mc delta T. So the mass we calculated to be 0.09325 pounds times CV, which we said was 0.177 BTU per pound R, multiplied by a change in temperature of T2, which we wish to solve for, minus 560, which is T1, and that's in R. So we have only one unknown in this equation, which is T2. So if we rearrange this equation, we find the temperature of the nitrogen after the paddle wheel has done 5,000 pound-feet of work to be 949 R, which is equal to 489 degrees Fahrenheit.